quick example over here. So we've got the straight line equation. And let's say I start off with the first part over here, right? I'm going to change this value, c, into whatever number this is. Whatever number goes through this axis is going to go there. So that value and that value is always the same. The number that's not with x, the number that's alone by itself, which is also your constant. All right, so your constant is your y-intercept. Okay? And that'll be at the bottom there. What is this axis called, this vertical axis? Thank you, Daniel. Daniel says an equation is sort of a number sentence that includes pronumerals and also contains a left-hand side and right-hand side. Perfect. That's an equation. Good. This is an equation. It's got a left-hand side and it's got a right-hand side. The left-hand side is your y value, which is your y-axis. And the right-hand side here carries this value, which is your x-axis. And this line shows us how x is changing as y is changing along the way. But let's look at how this can be displayed in a table form. I'm going to produce some x values and y values and an equation. All right. So let's suppose I got the equation y equals 2x plus 1. I'm going to give some x values. And when I put the x values in, it's going to shoot out some y values. Then we're going to plot it. Okay. Going to go with a few negative values, 0, and a few positive values. And this is a table of values like this. I'm going to make x negative 2. When I put negative 2 into this equation, what does it look like? It looks like this. Y equals 2, and the x is now negative 2. So that becomes negative 2. What does this mean? This means times plus 1. So I rewrite that and I change x into negative 2. 2 times negative 2 is negative 4 plus 1. So y is equal to negative 4 plus 1 using integers. Negative 4 plus 1 gives me negative 3. So the answer for this here is going to be negative 3. Hello. Did someone say hello? Okay. All right. You can unmute yourself. No problem. And then negative 1 is now going to become this. So y equals 2 multiplied by negative 1 plus 1. Because now the x value is becoming negative 1. That's going to become y equals to negative 2 plus 1. Negative 2 plus 1 is negative 1. Okay? Negative 2 plus 1 is negative 1. So that means this is going to be negative 1. If I put 0 in there, what's going to happen? All I got to do is change this number into 0. What's 0 times negative 2? 0, right? So this is going to be 0, and 0 plus 1 is 1. Okay, so this is going to become 1. So I put 1 over there. What's happening every time I go from one number to the next? Type it in there. What's happening? How do I go from one number to the next? If I make this 1, 2, and 3, how do I get those bottom numbers? Can you see the pattern? Plus 2. Plus 2. That's right. Yeah. So I'm plussing 2 every single time. So the next one, I can just work it out. It's 3, 5, and 7. Now, when I plot this, I've got to plot my x values and I've got to plot my y values very carefully, okay? So from here, I'm going to make this a little smaller. I'm now going to plot this on and x's. Okay, so here we go. That's my x's being drawn. What's the vertical axis called? Y. What's the horizontal one? X. And now I'm going to start from -2. So let's make this -2, 1, 0, 1, 2. -2, -1, 0, 1, 2. And then when I got -2, I got -3. So I got to go all the way down to -3. So let's say -1, -2, -3 on the y. That's going to be there. -1 and -1 will be here. 0 goes to 1. So over there. 1 is 3. 2, 3. There. 2 is 5. 4, 5. It's over there. And what do we have here? Straight line. That's a straight line. At least I thought it was. Okay, so ideally it's supposed to be straight. Maybe if I do that, I could possibly just adjust those values in there. The numbers have to lie on the line. Okay, when you draw it. What's the problem with this? It took forever to do. Do you agree? It took really long to do, to draw this line. There is a quicker way to do this as well. So now, can you see this is +1? +1 is over there. So you'll notice that value is known as your y-intercept. This number over here is known as your x-intercept. Now, how can I draw this in a different way using the y-intercept and x-intercept? Let's see. I got the equation y equals 2x plus 1. It took a long time to do the table. Now I want to find a different way to do this now. So what I'm going to do now is I'm going to show you how to do this without drawing up the table. The first thing you're going to do is make x equals 0 inside your equation. So you're going to make that value equal 0. So therefore, you're going to end up with y equals 2 times 0 plus 1. That becomes y equals 0 plus 1, which is y is equal to 1, which is over here. How do I write this coordinate? X is 0 and y is 1. Because every coordinate, and that's going to be this coordinate over here. That's this coordinate over there, right? 0, 1. The next thing I'm going to do is make y equal 0. Make y equal 0. And when I do that, I got 0 equals 2x plus 1. Now I have to solve for x. And we know how to solve equations. We've done this, right? Solve for x. So I'm going to move the plus 1 over to the left-hand side. It's going to become -1. And then I'm going to divide both sides by 2. So x is going to become -1/2. So -1/2 will be over there. How do I write this coordinate? X, y. All right? So that's going to be those 2 points. And believe it or not, that's all I need. That's all I need. And I can do that faster. And there we go. That's my straight line. The exact same straight line using the table. I've now drawn it using that. So what was the main thing behind this? What was the first thing I did? Who can tell me? What was the first thing I did? Yeah, I made x equals 0, right? And then I got y. What's the second thing I did? Make y equals 0 and then I got x. Then I plotted the points, plotted the x point there, I plotted the y point there, and I was done after that. Cool? Do you think you can do this? Hey, do you think you can do this? Are you ready to try one? I'm going to give you an equation. You're going to make x equals 0. You're going to get y. Then you're going to make y equals 0 and get x. Okay? Let's try it. Let's go back to basics. Let's just keep it basic for now. Here we go. I got y equals 3x plus 1. Make x equals 0, type y. What do you get? Make x equal to 0, and what is y? Type your answer. Okay. What is y? Equal to when x is 0. Thank you, Daniel. Well done. Anyone else? Make x 0, type y. Get your answer. Y. Here we go. That's all you got to do is this. Watch carefully. 0 goes in there. What's 0 times 3? 0 times 3 is 0. 0 plus 1? 1. Okay. Go and change this equation up. This equation is now going to be 4x plus 4. Make x equal to 0. What is y? Well done, Harrison. Well done, Lucia. Well done, Sophia. So when x becomes 0, 0 times 4 is 0. 0 plus 4 is 4. Let's try it again. Let's suppose I've got now 3x minus 4. Let's make it minus 9. What will y be when x is 0? What will y be? Well done, Sophia. Good job. Well done, Harrison. Good job, Daniel. All right, keep those answers coming. I've got the same people answering the same questions. If there's anyone who's not answering, make sure that your camera is on. All right, or you answering. Perfect. -9 all the way through. Thank you, everybody. Okay, good. That's going to be -9. Now we're going to take the same equation and I say make y equal to 0 now. What will x be if y is 0? Is it +3 or -3? Well done, Sophia. Well done. I forgot whose iPad. Whose iPad again? Type your name again. Leo. Well done, Leo. Cool. Well done, Lucia. Well done, Daniel. The answer is 3. How do we know the answer is 3? Because let's suppose this number is not here and this number is 0. 9 minus 9 is 0, right? So this must be 9. So this can be 0. But for this to be 9, this needs to be 3. Can you see that? Because 3 times 3 is 9. So what is x? 3. What will x be now? Good job, Leo. Think carefully about this one. Something minus 8 is 0. Well done, Lucia. Well done, Harrison. Something minus 8 is 0. So this number here needs to be 8, right? 8 minus 8 is 0. So what must x be if this is 8? 4. Well done, everybody. Okay, you guys are getting there because this is going to be 4 because 2 times 4 is 8. And 8 minus 8 is 0. So 4 is what we're looking for this one. On the next one, I want you to find the x-intercept and the y-intercept. Y is equal to 3x minus 6. I want you to make x equal to 0. Tell me what y is. Then I want you to make y equal to 0 and tell me what x is. All right, I got x equals to 2 coming through and y equals to negative 6. When x is 0, y is negative 6. So well done to everyone who got that. When y is 0, this number needs to become 6. So this number needs to become 2 because 3 times 2 is 6. So this will be 2. So well done if you got 2 and negative 6. Now keeping that in mind now, I can develop coordinates. All right, let's develop some coordinates about this ones. So when I develop a coordinate, I put the x value first, 0, and the y value second. And then I put the x value first and then the y value after that, like that. So now when I draw this, I gotta go 2 to the right and 0. Then I got negative 1, 2, 3, 4, 5, 6. So negative 6 down. And that is the 2 points I connect to get my straight line. And that's my straight line. Done. I've now drawn it. There's a point 0, 2 and 0, negative 6. Does that make sense? Everyone understand that? Yeah? Yep. Okay. This is called equation of a straight line. What you notice about the number over here, -6, it's at the bottom there. Okay. All right, cool. Now we're going to move on to a concept called gradient. The concept of gradient is basically built on the following fundamental. If I've got 2 points, x1 and y1, and I've got x2 and y2, the gradient formula says to measure the length of a slope, not length of a slope, the gradient of a slope, we use the gradient formula y2 minus y1 divided by x2 minus x1. Now, what does this mean? Let's suppose I have certain values, like, let's say I got 0, 4, and 6, 0, a y-intercept and an x-intercept. y2 minus y1 is 0 minus 4. x2 minus x1 is 6 minus 0. Minus 4 divided by minus 0 can't, so we're left with minus 4 at the top. 6 minus 0 is 6, and when we divide by 2, becomes -2 divided by 3. Did you see that? What happens if I've got different values here? Let's say I got 2, 4, and 7, 9. Remember, I got to take the 9 minus the 4 divided by 7 minus the 2. That's going to be 5 over 5, which is equal to 1. And that's my gradient. My gradient for this one is that. My gradient for this one is that. Write this formula down. Write down y2 minus y1 over x2 minus x1 somewhere so you can use it for the next question. Write it somewhere. You got it? You guys got it? Yeah? Okay, good. Now, write this next two numbers down. Write down 2, 3, and write down 4, 7. You got it? Remember, this is x1, y1. This is x2, y2. Now, let's go through this. We got y2 minus y1 over x2 minus x1 is going to give me my gradient. That's what I want. So what's my y2 going to be? 7 minus 3 divided by x2 minus x1, 4 minus 2. 7 minus 3 is 4, 4 minus 2 is 2, 4 divided by 2 is 2. Are you ready to try this? Yeah? All right. You got the formula? I'll just write it at the top here. y2 minus y1 over x2 minus x1. If I give you 2 and 4, 7 and 14, what is my gradient equal to? Type it in. Cool. I think we got an answer here. Here we go. So let's go 14 minus 4 over 7 minus 2. That's going to give you 10 over 5, which is equal to 2. So well done for those who got 2. All right, I'm going to give you a set of numbers now of coordinates. I've got 3, 4, and you're going to find out the gradient for each of these. Your time starts now. Let's see if you can do this. It's now 5:23. 5:23. 4 questions in 4 minutes until 5:27. Let's see if you can get it all. 4 minutes. Get me the gradient. Don't forget, right? Find the gradients. 1 more minute left. Let's see if you can shoot out whatever answers you got. Type those answers in. Send those answers through. Calculating the gradient y2 minus y1 over x2 minus x1. All right. Some of you are not answering. You have to put your camera on if you're not answering. Don't forget that. Okay, Daniel's been sending answers. Harrison, Lucia, Sophia now. All right, keep those answers coming. All right, so please put your cameras on. Okay. Okay. Here we go. So the first answers here, let's have a look at these now. This is what we're going to do. I'm going to minimize this now. We're going to find out each of these gradients as fast as we can. So question 1, it's 18 minus 4 over 10 minus 3. Question 2, 10 minus 18 over 2 minus 4. Question 3, 8 minus 5 minus 4. That's one you have to be very careful. There's two minuses here. So minus 3. And this one here, question 4, minus 6 minus 3 over 3. Again, two minuses. 3 minus minus 6. 3 minus a negative 6. Like that. 18 minus 4 is 14. 10 minus 3 is 7. That's negative 8. Negative 2. That becomes 4. That'll be 3. Negative 4 plus 3 is negative 1. It'll come to negative 3. Negative 6 minus 3 is negative 9. And 3 plus 6 is 9. So it'll be negative 1. 14 divided by 7, by the way, is 2. So that's your answers. Question 1, 2, 3, and 4. Well done for those who got it right. This last one here, 3 minus minus 6. You see that minus, and the minus means it becomes a plus. This one as well. Quickly mark that. All right. And then we'll look at rise over run.
So I've got my...
All right, I'm still here. I'm now going to quickly go into this video. I want you to watch this video over here. I'm going to be sharing sound now. All right, here we go.
What I want to show you now. The equation for the slope of a line looks like this. Slope equals delta y over delta x. Remember that the fraction line means division. So delta y over delta x is the same as delta y divided by delta x. You might also see the slope equation written in expanded form like this. The only difference is that the delta x and delta y have been written out to show the subtractions you need to do to get those values from the coordinates. Either way you want to write it is fine. And some of you may have heard this same equation expressed using different terminology. Have you ever heard someone say that slope equals rise over run? Rise and run are just different names that are sometimes used to describe the change in y and the change in x. The idea is that if you were to run along the line in the x direction, you would rise by a certain amount while you did that. Or would you? What if the line has a negative slope, which means that as you move in the positive x direction, the y value decreases instead of increases? That would be like going downhill instead of uphill. And the word rise seems less fitting in that case. Because of that, we'll just use delta y over delta x in this video. But it's certainly not wrong to use the terms rise and run, especially if it helps you remember the formula. But if you do, just remember that the rise can also be negative. Now that you've seen the equation for slope, let's see the equation for calculating the distance between 2 points on the line. Distance equals the square root of delta x squared plus delta y squared. Does this equation remind you of anything you may have seen before? It certainly reminds me of something I've seen before. You stole my theorem. Hi there, Pythagoras. I didn't steal your theorem. I'm just borrowing it so I can calculate some stuff. Don't worry, I'll give you credit for it. Oh, well, I guess as long as you give me credit. Do you remember how the Pythagorean theorem tells us the relationship between the three sides of any right triangle? That means that if you know the lengths of two of the sides, you can calculate the length of the third side. Well, we just saw that if you turn a line segment into a right triangle, you can calculate the lengths of two sides, which would be delta x and delta y, right? So we can just plug those values into the Pythagorean theorem. You're used to seeing that theorem in this form. A squared plus b squared equals c squared. Since a and b are the lengths of the horizontal and vertical sides, we can plug in delta x and delta y instead. And instead of c squared for the hypotenuse side, let's use d squared because the length of the hypotenuse equals the distance between our 2 points. To solve for d, or distance, we take the square root of both sides and we get d equals the square root of delta x squared plus delta y squared. This special form of the Pythagorean theorem is usually called the distance formula in algebra because you can use it to find the distance between any 2 points on the coordinate plane. And just like with the slope equation, you'll often see it in expanded form, where the delta x and delta y are written out as the subtractions x2 minus x1 and y2 minus y1. Alright, now that we have our equations for slope and distance, let's see them in action. Suppose we're given two coordinates, and we're asked to find the slope of the line they form, and the distance between those points on the coordinate plane. The first thing we need to do is name the coordinates, since they aren't named already. And even though it's not really necessary, if you're like me, you might want to draw a little sketch of the problem to help you visualize what's going on. The equations for slope and distance both use delta x and delta y, so let's calculate those values first. Delta x equals x2 minus x1. And in this problem, x2 equals 4, and x1 equals negative 2. So delta x equals 4 minus negative 2, which is just 6. Next we calculate delta y. Delta y equals y2 minus y1. And in this problem, y2 equals 3, and y1 equals 0. That means delta y equals 3 minus 0, which is just 3. Great. Now we have our delta x and delta y values. And you can confirm that we got them correct by looking at our graph. The length of the delta x side is 6 units, and the length of the delta y side is 3 units. Now let's plug those delta values into the equations for slope and distance. Slope equals delta y over delta x. We just found that delta y equals 3 and delta x equals 6. So our slope equals 3 over 6, which simplifies to 1/2 or 0.5. That was easy. Now let's plug those deltas into our distance equation to see how far apart those points are. Doing that tells us that the distance equals the square root of 6 squared plus 3 squared. 6 squared equals 36, and 3 squared equals 9. 36 plus 9 equals 45. So the distance between the points would be the square.
In this activity, you can see that if I go from my y-axis, now start from my y-intercept, and I'm going to go right and up. I have to go right. Let's say I go 3 units to the right and I go 3 units up. What is my rise here and what is my run here? My rise and run. My run is +3 to the right and +3 up. So this gradient is always the vertical number divided by the horizontal number. So +3 divided by +3 comes to 1. Let's have a look at this one. This one here, I start from the y-intercept. I go 1 to the right, so that's +1. But then I go 2 units up, that's +2. So the gradient here is going to be +2 divided by +1, which is equal to 2. Does that make sense? Yeah? Let's suppose I go to a negative gradient now, something like this one on the far right here. This one here, if I start from the y and I want to go back to the line, I got to go left. So that's -3. And if I go up, that's +3. So whenever you go up, it's plus. Whenever you go down, it's minus. When I divide this, I take the top number, which is +3, and I divide it by the bottom number, which is -3, and it comes to -1. So the gradient for this will be -1. Okay. I want you to try all of these questions quickly. Check into the chat and begin that activity on gradients. We're then going to move into a Kahoot. You got 5 minutes to practice a bit of gradients and straight lines. We're going to do a Kahoot in 5 minutes.